Thank you, everyone, and thanks for coming. Is this thing on or not? It's on. Okay. So today we're going to talk about the differences in Solana and Sui. I know a lot of you, or a lot of people, are familiar with Ethereum, so I thought, why not just, make a presentation about other ecosystems which are less frequently met in academia. Who here has already deployed or written programs or smart contracts on Solana? And then how about Sui? Okay, cool. So for those people, this might be boring, but we're going to try to keep it interesting. A slide about myself so that you get an idea of how old I am. And like age indicates wiseness, so hopefully you get something out of this presentation. More recently, I've started my own audit firm, and we mainly focus on Solana and Sui, hence the topic of this presentation. So the agenda for today is we're getting a bird's eye view of the architecture, some network properties that are popular and important. Then we're looking a bit into the programming model and talking a bit just briefly about the languages that each of these ecosystems use. We're going to see some developer perspectives, what developers need to keep an eye out for, and then some user perspectives. Finally, we're going to dive into two security incidents because we don't have so much time. And we're going to conclude with a comparative analysis and draw some conclusions. So to start off, let's look at Solana first. It basically everything is an account, right? It's sort of like account based, and Sui is like object based. So it's high speed and it's a monolithic chain. It uses the Rust programming language, and it's stateless. So the program and data are kept separately, and each of them is an account. And it can handle routinely between 3,000 to 5,000 or 6,000 transactions per second. And there's a new client that is being developed by Jump, which is called FireDancer. And it's built for performance. So these guys at Jump are hardcore at high frequency trading. Performance is everything. So it's written in C++. Actually, just C, not even C++, because C++ is too slow. So it's just written in C, and it's all about performance. And in theory, or maybe even we'll see once it comes out, it can handle 1 million transactions per second. In terms of validators, much smaller set than Ethereum, so it's around 1.5K, out of which probably 1K are active on a day-to-day, in the past few weeks. And then the consensus algorithm being used is practical BFT. But quite recently, just in May this year at Accelerate in New York, the Alpenglow consensus was announced, and it's 100x improvement in terms of everything, transactions per second and everything there. So it's still a leader-driven block proposal. So there's a leader that is elected that proposes the block. And now we're going to see Sui. The differences, so a comparison, like I mentioned, it's object-centric. Everything is an object, even the assets. They're not balances, they're objects. So we're going to see that in the next slides. And it uses this Move programming language, which was built for Libra. If anyone remembers Libra from a few years ago, this Facebook-led initiative or Meta-led initiative, which had a lot, I think dozens or over a dozen big institutions. And then it just got axed, I think, along with the FTX crash. But there were a lot of other blockchains that spun out of that effort, like Sui and Aptos and others. And they still use this Move programming language because it's pretty cool, both from a developer experience as well as from a security perspective, so a security researcher perspective. And it has this you know, resource semantics and linear logic, which is very helpful. We're going to see in the next slides. And I just took these numbers from, you know, Sui scan. It's between 10 and 5,000. Like at the peak, at some point a few years ago, it reached 5,000 transactions per second, but that's not typically what the chain sees. And it uses this Mistichetti consensus protocol, which in theory, in the paper, it can handle up to 120,000 transactions per second, but simple transactions, so just native token transfers. And the set of validators is about 10x smaller compared to Solana. It's an emerging ecosystem. The interesting thing is that the consensus protocol is collaborative. So it basically allows all of the validators to propose blocks. At the same time, they go into a DAG, a directed acyclic graph, and at some point the leader proposes an ordering block, which sort of fixes, you know, the ordering of all of those blocks. So now let's dive a bit deeper into what does account-based architecture mean, right? Like I mentioned, everything is an account. You can see the program is an account. You have like data accounts, and you know, you need to specify whenever you have a transaction. You need to specify all the accounts that that transaction will touch. So, yeah, the programs do not contain the data themselves like they do in Ethereum, and the developers have this sort of burden that they cannot just dynamically create the address of the smart contracts that they're going to interact with. They need to specify them up front when they submit a transaction, and the benefit of this is that you can do parallelization, right? Once you know everything that's going to be touched, that allows you to do more parallelization, which means more transactions per second compared to Ethereum, which doesn't have this feature. In contrast to this, Sui is object-centric. So everything here is an object. You have a coin module. You have these modules. So the modules are like the programs in Solana. They're the code. And then you have instantiations, right, of these modules, which are the actual, you know, object that you as a user use. But everything's an object, right? And yeah, yeah. I forgot what I wanted to say here. Sorry about that. So the transactions, they directly change the ownership of these objects. So you basically have in each object, the most important thing is who's the owner, right? Who owns this object, and who's going to own it after this transaction is over. So this is being updated in the global ledger. And yeah, the benefit of doing this and using this model is that for very simple native transfers, you don't need to have consensus with all the different validators. You can, you know, do it much faster, and that's how it reaches 120,000 transactions per second when you do these kind of simple native token transfers. Now, we talked a bit about, a few slides ago, about transactions per second, and I wanted to give you more than just one number. So here's how the TPS looks like for Solana in the past. Yeah, it's basically all time, so years. And you can see it started off around 2K transactions per second, and it gradually grew, and now it's around 4K. And of course, we had like a more heated period, especially around the Trump and Melania coin launch, where the number of transactions per second was way higher. And for Sui, it looks a bit different. So here you can see it has reached and surpassed 5K transactions at some point in 2023, but on a daily basis, it's, you know, just 100 or a few tens of transactions. That's where it peaks. Now, it doesn't mean that it cannot do more, but it's just not as used as Solana at the moment. Now, let's look a bit at the programming models and languages. We touched a bit on this. Solana uses Rust, and account metadata needs to be passed in by users. And that means that developers need to check if the signers, so the owners of these accounts, are the right people that need to manipulate this program. Otherwise, they get into access control vulnerabilities. And it does this using, it processes transaction using optimistic concurrency. So it can do a very high throughput, as we've seen in the previous slide with the number of transactions per second. So yeah, it's very powerful in terms of speed and performance, but it does leave this safety check in the hands of the developers. And we're going to see later an attack that shows how important that is. In the Move ecosystem, yeah, everything is an object. So because Move was designed with this kind of security in mind, these objects cannot be cloned or duplicated, and they cannot be destroyed without a trace. So everything can be tracked back to where it originated from. And this linear type system, it basically completely eliminates reentrancy. So reentrancy attacks should not be possible. We'll see. We haven't seen any in the wild yet. So, Also, I remember when Solana came out, there was this strong emphasis on reentrancy attacks are not possible. But still, there's one type of reentrancy that has to do with the same account calling itself, which is still possible. So, yeah, we've seen that also in the wild happening. And in terms of ownership tracking, this is something that is very cool in the Move ecosystem, that you can easily track who was the old owner, who's the new owner, and they have the bytecode verifier, which is done at compile time, that basically prevents bad things from happening. So this ecosystem, in theory, should be super safe. They also, because of this strong type system, they have already very good formal verification tools that are out there. So auditing firms that do Sui audits, they can readily use formal verification tool that prove correctness with respect to certain properties. In terms of native token transfers, because we know Sui can reach its peak when it does no native token transfer, we wanted to take a quick look at how that is done under the hood. So first in Solana, maybe you already know this, everything is handled by the system program. So you have this central system program in Solana that is called whenever you need to do a token transfer, and the user needs to specify from which account. They need to be the owner, the signer of that account. They transfer it to a different account, and the balances are just updated atomically. So before the transaction, you had Alice with 5 SOL and Bob with 2, and let's say there's 1 SOL transferred. So the system program is called, which checks if the signer of this transaction is Alice, and if it is, they decrement Alice's account and increment Bob's account. Everything happens atomically, and this is stored in the global ledger. On Sui, this is quite different. So we have here, imagine these as columns: before transfer, after split, and after transfer. And the first step is Alice wants to send 1 Sui to Bob, right? They split this balance, this object, this coin object that is owned by Alice. So this is not Alice's wallet. This is not Alice's wallet as we saw in the previous slide. This is Alice's coin. It's an object, right? You see the value is 5 Sui and the owner is Alice. Then you have this split phase where this Alice coins is split into another smaller amount with 4 and a new coin which is 1. And this belongs to Alice at first. And then in the next step, the ownership is transferred to Bob. So here you can see the owner has changed from Alice to Bob. And at this point, Bob owns this coin. And this is why, consensus can be bypassed when you do this, and you can do so many different token transfers in 1 second. Now let's look a bit at developer and user perspective. So from the developer perspective on Solana, like we said before, you must explicitly check the signers to know who's the owner and if they're allowed to do the action that they're trying to do. So this is, for auditors, very, mandatory to check, but it's also very tedious. You might miss this, and we're going to see in the exploit that we're presenting that something like this was missed. It has existed for quite a while, so it's more than 3 years, more than 4 years now, and it has a very thriving community and a rich tooling associated to it. From the user perspective, it's a very liquid network. It's very fast. Transaction fees are very cheap compared to Ethereum. There have been some outages in the past, but the chain has come back, and it's alive and kicking. And we've seen even in the past year, in December, I think there were some supply chain exploits that can impact wallets. We've seen some this year, even like at the beginning of this week. It wasn't specifically on the Solana chain, but it involved something with Solana. So supply chain attacks, they also apply to Sui. But here, what we want to emphasize is that developers, from a developer perspective, Move is very enjoyable. It's a nice programming language that is intuitive. It has this type safety. It has already formal verification tools, but it is a smaller ecosystem. So there are overall fewer tools available, and fewer tutorials, and fewer documentation, or like YouTube videos or blog posts. Users, they are protected by the private keys, and everything's an object, right? So the Move semantics gives this sort of built-in protection, which is very comforting as a user. But it does mean that since it's an earlier ecosystem, only like 2 years old, it has fewer dApps and a smaller validator set. In terms of how access control works for Solana and Sui, we're going to take again a first look at Solana. And here, we can see that any transaction, so let's assume like there's a transaction being sent by this admin signer, and on the bottom left there, it is first checked by the token program who has the logic. So this is it's not visible, but at the top you have the token program, which contains the logic, not the data. And it verifies if the key stored inside of the config account, here on the right, matches the key of the admin signer. And if it doesn't, it fails. If it does, it goes through. Another cool thing in Solana, which is pretty unique, you have these PDAs that allow programmatic access, to these assets without needing a human user in the loop. So you don't need the human user to have a private key. It just derives a private key from an authority and a program ID. And this is just stored by the PDA. And the config account has the associated PDA, and the PDA is allowed to do token transfers. So this is something which is very handy. In terms of Sui, access control is done very differently. You have, again, objects. So you have capability objects. That's what admin cap is, from admin capability. And you have these objects. If you're the owner of that object, you have the capability to call this update balance function, right? So here, the admin owns that object. he can call the function. Regular user doesn't have that. He cannot call that function and therefore cannot update the treasury object. I'm going to try to speed up a bit. I have just a few minutes. Now we get to the juicy part, the security incidents. Here's a very, very high-level simplified version of the code, and I'm going to sort of walk you through it step by step. On July 9th, an attacker exploited this vulnerability in the rebalance feature of the texture vaults. This is not the rebalance function, it's just the snippet inside of the rebalance function. And the point here is that, this is the important line. This account was not checked properly, like we've been discussing over the previous slides. And the attacker could just say, hey, when you're minting these LP tokens, just mint them to my account, not to the account of the protocol account, right? So that was the flaw, the missing ownership check here for this account, and which allowed the attacker to insert, their address. They minted about 2.2 million worth of LP tokens, and then they just, withdrew those LP tokens for USDC. Only the USDC vault was affected. The team did a fantastic job. They reacted swiftly. They secured the protocol, offered the hacker a 10% bounty. He took it, returned the funds, so everyone's happy. The key takeaway here is that, even if the audit of texture finance was really, focused on really complex exploits, really tricky things, subtle thing, this basic type of vulnerability still needs to be checked very meticulously, even if it's tedious. Now, in Sui, we have all these different things that help you. I'm not going to go over them because I don't have too much time, but we have all these different things that help you improve the security. What do you guys think? Are hacks still possible? Who thinks hacks are still possible? All right. So we had this exploit of the CEDAS protocol, which is a very important exploit. And I think it brought more maturity to the Sui ecosystem because they realized even if the language is built with security in mind, you can still have certain types of vulnerabilities that can lead to big major losses. On May 22nd, this is when it happened, and CEDAS was the main DEX on Sui, and it was also deployed on Aptos. And the flaw was an arithmetic overflow bug, so traditional arithmetic overflow that you learn about if you studied computer science and basic programming or one-on-one on security. It's one of the traditional bugs that were also present in Ethereum when it started. And here you can see there were two bugs. One was this mask here, which was crafted for 122 bits instead of 256. And the second one was an off by one check. Here, it should have been greater than or equal, not just greater than. And those two things combined basically canceled out this abort in case of an overflow. They did check for overflow, which is good. Like they were aware that an overflow could happen, but because of the mask combined with this off by one error, the attacker could craft the exact thing that was missed by one thing and avoid this abort. And basically the attacker created, again, a lot of LP tokens, concentrated liquidity in certain very small and narrow price range, and was able to drain 223 million, which is very impressive for the size of the ecosystem. The key takeaway is that even if the language is built for security, you might still be vulnerable to other types of vulnerabilities. Even if the reentrancy is totally eliminated from Sui, you might still be vulnerable to such arithmetic issues, which seem to be very popular by black hats to exploit these days. Quick comparison, you can see here the Solana ecosystem is more mature and Sui is emerging. Everything is about 10x difference, except for the number of projects and the amount hacked. So with that, I want to conclude and make the point that both ecosystems are challenging, or are the challengers for Ethereum. Sui is definitely something to keep an eye out for. Solana is tricky to audit, especially because of those signer checks. And even if Sui, the move language, is built for security, you still have third-party library vulnerabilities and arithmetic bugs and other types of bugs that plague the ecosystem. Thank you very much. Sorry for being over time. Hope you liked it.